Okay, let's take a look at our second project. This is how to create surveys that have the correct percentage of people. So the first thing I'd ask you to remember from an algebra class is that base times percent is amount. So let's look at a simple arithmetic example of that. This first example says that if 10% of the people at the airport are elderly, and there are 270 people, how many are elderly? And that's a simple enough matter. We simply say 10% of 270 is 27. Now remember that of is the key word for multiplication. So 270 of 10%, or 10% of 270 is in fact 27 when we multiply. The second question reminds us how tables are used. So if it's been a while, this is how we solve questions like this. So we're not doing algebra with this. I'm just showing you how a table works with this example. It says a statistician surveys 400 people on the bus and 600 people at the airport. So the first thing we know is the bases. We know that there were 400 people on the bus. So we put a 400 for the base in the bus riders row, and 600 people at the airport, so 600 in the airport row. Now that tells us that our sample is 1,000 people. So when we add those up, 400 plus 600 is 1,000. So we've completed the first column. We know everything about the base. The second sentence tells us that 10% of those who fly are elderly. So at the airport, the percentage of what we're interested in, elderly folks, is 10%, while 20% of those on the bus are elderly. So 20%, the percentage of folks on the bus who are elderly. Now we can't simply add those up. That's not the way the world works. You don't add weak to strong and get stronger. You don't add weak to strong and get weaker. You add weak to strong and get something in the middle. And so we don't know what that sample percentage is yet, and that's okay. We're going to keep working. The next sentence says, complete the table. That's easy enough. Just like our first example, we know a base and a percent. So let's look at the bus riders row. 400 times 0.2, that is 20% of 400, gives us 80 bus riders who are elderly. And in the next row, the airport row, 10% of those 600 people are elderly. 600 times 0.1, or 10% of 600, is 60. And we can add those together. So we know the total, the sample size, the number of elderly folks, the total sample amount. And just the way we did for the base column, we add the amount column. Now we can find the percentage, because we're told that of those 1,000 people, 140 are elderly. Well, that's 14%. So just like any mixture problem, we end up with a percentage not as small as the weakest value, that is 10%, and certainly not as large as the strongest value, that is 20%, somewhere in between. 14 is between 10% and 20%. Our next example asks us to do a little algebra to figure out how to create this study. It says a statistician needs a sample of 1,000 people, that is 18% elderly. On the bus, 20% are elderly. At an airport, 10% are elderly. How many of each population should be surveyed? So we see that this is a mixture problem. There's the table created for us, base times percentage is amount in our columns, and then our rows, the bus riders, the folks at the airport, and then the completed sample. Let's go back through this again and put in the information as we find it. The first thing that we learn is that we need a sample population of 1,000 people. So some of those on the bus and some of them at the airport, but 1,000 total. And that population needs to be 18% elderly. So we know the goal for our population, that is that 18% of those 1,000 folks are elderly. Just like before, 18% of 1,000 is 0.18 times 1,000, or 180. We completed the bottom row. The bus, 20% of folks are elderly, so we're going to put in that percentage. There's 20% in the bus riders row in the percentage column. At the airport, 10% are elderly, so again a percentage in the percentage column, but now in the airport row. And just like you'd expect, that mixture, that 18%, is between 10% and 20%. And then it says how many of each should be surveyed. And at this point we see that we need variables because we don't know how many bus riders or how many folks at the airport are surveyed, just that the sum is 1,000. So you can do this with two variables, and I'm perfectly fine with that. If you put in an x and a y and solve a system, that's perfectly fine with me. But once you left beginning algebra and we're in intermediate algebra, the subtraction property is fine too. So I'm going to use the subtraction property because you've already been through three variables. You know how to do that in general. So a shortcut now and then isn't a problem. So we're going to give a variable to the number of bus riders. We're going to call that x, an unknown. Now, if you put a y in for the number of folks at the airport, you'd be solving a system. Nothing wrong with that. I'm going to use the subtraction principle and say that if I've got 1,000 people and I take away x of those because they're bus riders, the rest must be folks at the airport. That is exactly what subtraction does for us. So 1,000 minus x. And now that I have the basis, I can multiply across. So let's look at that bus riders row. It says that the base is x and the percentage is 20%. Well, that's 20% of x, 0.2 times x. And similarly for the airport row, 10% of that base of 1,000 minus x. Now, notice that, and I'm sure you remember this, but it's good to remind yourself of this. The equations in the base column, that's a tautology. It's always true for any x. So that's not going to tell you anything. It basically says that x plus 1,000 minus x equals 1,000, which is true for any x. Now, that doesn't mean that it's a useless equation. It just means that it has not any more information to give us itself. So, of course, our equation that we're going to solve is in the amount column, and we're going to say that the number of bus riders who are elderly, that's 0.2x, added to the number of folks at the airport who are elderly, that's 10% of the total number of folks we survey at the airport, is our desired total elderly population among the survey, 180. So that gives us an equation lickety-split, and before you can say lickety-split, we're going to get rid of those parentheses using distribution. So I'm going to distribute the 0.1 into the 1,000, that'll give me 100, and into the opposite of x. So all I'll do in the next step is the distributive property, cleaning up those parentheses. Now, I notice that I have two variable terms. The first term and the third term on the left side are both counting x's. 20% of x and 10% of x, well, that's 0.2x minus 0.1x, and so we do the arithmetic. 0.2 minus 0.1 is 0.1. 20 cents minus 10 cents is 10 cents. So we've now done all the arithmetic on the left side. Now it's time to do some algebra. We're going to undo, and we're going to work backwards through the order of operations. So the first thing I'm going to undo is the addition, because that's the last thing that I would do if I was actually performing the arithmetic over there. In other words, I do the multiplication and then the addition, so I'm going to undo the addition first. Adding 100 is undone by subtracting 100, so I'm going to subtract 100 from both sides. And now we've got 0.1x equals 80. We're going to divide both sides by 0.1 to undo the multiplication on the left side. Now, when you divide, some people think you should get a smaller number, and sometimes you do. But if you ask the question, how many dimes are in $80? That's exactly what this question is asking. If you've got $80, that's the 80 on the right side, and you're counting those in 10-cent pieces, that is dimes, you're going to see that each dollar of those $80 gives you 10 dimes. So dividing by 0.1 is counting by dimes, if you're thinking of dollars. And so that's going to give us 800. So we've got x. So let's plug this in and see what we've got. So taking the place of x is 800. Our total is still 1,000, and the subtraction principle says that 1,000 minus 800 is 200. So that subtraction principle simply says whatever the number of bus riders is, you take that from the total, and you're left with the number of folks at the airport. So exactly what you'd expect. And the percentages haven't changed, so we simply recopy those. And now we multiply across. And hopefully when we add down, we'll get that 180 again. We know that it should add to 180, so let's find if it does. Remember, we're checking at this point. 20% of 800, that first row there, is 160. So 10% is 80, 20% is twice that, or 160. 10% of 200, well, 10% is just saying a tenth as much, so a tenth of 200 is 20, and they add perfectly. 160 plus 20 is 180.